This is Cryogenic Treatments presentation presented by Iman Tura,
Shirley Harmon,
and Jonathan Shackle. Cryogenics is a modification to living organisms or metals for enhancement purposes. It uses extremely cold temperatures to do this. The two major types of cryogenic technology are cryogenic treatments, which focuses on metals, and cryotherapy, which focuses on living things for medical concerns. Two types of cryogenic treatments are used for materials: shallow, -50 degrees Celsius to -100 degrees Celsius, and deep, -125 degrees Celsius to -196 degrees Celsius. Cryotherapy is also known as cryoablation, where gases are used.
cryoprocessing is used in addition to the heat treating of metals. This is a process we will see in a video on the next slide. This process of metallurgy for the specific AISI metal is shown in the image in the lower left corner. For metals, deflashing is used to remove excess materials that has leaked into the mold during the molding process. And deburring is used to remove any rough edges or ridges that form on the metal. Cryogenic treatments for cells are done in research environments. This process includes cooling, freezing, thawing, and recovery. One prominent study of this research done by Duangpeng Yang and Waki Li that determined that cryogenic treatments and cryoprotective agents determine the survival rate of organisms that undergo cryopreservation. So what we see in this video are stainless steel knives that are going through the cryogenic quenching process. They were hardened at 1,955 degrees Fahrenheit and were cryogenically quenched at -320 degrees Fahrenheit.
Current cryogenic treatment started in 1894 by Professor Heinrich Kamerlingh Onnes from the Netherlands. In 1908, he set up the London Cryogenic Laboratory and was the first physicist to liquefy helium gas. Liquefying gases was the first critical step for the development of cryogenic treatment. Many different researchers made small discoveries that led to the innovation of cryogenics, all of whom I have listed on screen. Since the discoveries these pioneers have made, there has been an increased use of cold treatment in medicine and industry dating back to 1945. In this slide, I present the cost of liquid nitrogen and argon gas, both of which are used to create cryogenic conditions. The cost of these gases vary based on the amount of gas, how the gas is used, and where it is obtained from can all impact the costs to create cryogenic technology. The cost of body treatment of warts, skin tags, etc. can cost differently than the cryogenic chamber session, which is roughly $20 to $80.
There are many benefits and disadvantages to using cryogenic technology. In metals, this technology enhances metals. It becomes stronger, more long-lasting. It prevents mold and degradation in the long run. Despite these benefits, though, in many metals, there are statistics that state that these metals perform the same regardless of cryogenic treatments applied. Applying cryogenic treatments to said metals make them not cost-effective or ethically correct for reasons you will later hear. In addition to this, cryogenic treatments can sometimes be applied to cells, tissues, and living organisms. Unfortunately, though, this can be a painful and sometimes harmful process. In research, it is incredibly effective because it allows one to observe the same organisms under constant conditions. But this also has ethical concerns that Shirley will tell us in a later slide. In addition to this, with today's technology, we have learned to freeze dead human bodies for later revival when the technology is created. Is this technology worth it though? It is an expensive pursuit that may not even be possible. This is both an ethical and a moral dilemma.
There are several implications in the use of cryogenics in metals. The use of cryogenics to assist in the cooling process of metals is a slow process and needs to be closely monitored and controlled. If there are any issues in the rate of cooling or heating, there can be flaws in the metal. The use of cryogenics can be used to strengthen and increase the longevity of metals, which can then be utilized in weapons and other destructive tools, which raise a question of acceptability. The primary material in the use of cryogenics is liquid nitrogen, and due to COVID-19, there have been issues in obtaining liquid nitrogen due to the increased demand for medical liquid nitrogen and oxygen. These demands have left little room for other industries. When it comes to the cell process, the freezing and thawing process can be very stressful on cells if not done properly. The stress can cause the lipids within a cell to start to deteriorate and could lead to instant cell death. There are strict requirements when it comes to the management of cryogenic process and cellular structures. Cryogenically treated cells must be handled quickly. If the temperature increases too rapidly, there could be damage to the cells. The strict storage requirements mean that finding transportation to meet these demands is also difficult. The increased demands of liquid nitrogen have made it difficult to obtain this product for research purposes. And there's more research that's needed to determine the full benefit of cryogenics in relation to cells. And with the shortages of liquid nitrogen, that may be difficult.
So, in conclusion, the cryogenic and cryotherapy that we have shown in these slides can be used in myriads of ways, all of which have many drawbacks and benefits. Throughout this PowerPoint, you have learned what cryogenics means, who invented this technology, and how it was developed. We learned the many implications of such technology, and that surprisingly, the use of cryogenics in metallurgy has ethical implications, just as we have ethical implications in freezing cells. Using the information presented in these slides, we hope you can apply this information to your opinion of cryogenics going forward. In these slides, you will find our sources.